So today our learning intention is to learn about the voltage dividers. And voltage divider is a very, very simple device. Which has a lot of practical applications. One of them is automatic control circuits. So due to the voltage divider, for example, air conditioning, when you set a certain temperature to turn it on, that voltage divider regulates when air conditioner will be turned on and off. How it's applied to those temperature control circuits, light control circuits, we'll learn later on. Today we're learning how the voltage divider is working. Let's consider the next circuit. And it's very simple. Voltage divider is just two resistors connected in series. And it has voltage in, and we can take voltage out from one of them. Let's say we take voltage out from the bottom one. So this is R1, this is R2. Let's, for example, let's say voltage in is 12 volts. R1 is 50 ohms and R2 is 100 ohms. Question is, what will be the voltage output of this voltage divider? What voltage will come out? As we know, in series, what we know about the voltage in the series connection? It's shared between the total voltage equals sum of the voltages across each resistor. So we will have that voltage in equal voltage across resistor 1 plus voltage across resistor 2. What will be the total resistance of this connection? How we find the total resistance in series connection? We add them. So total resistance equals R1 plus R2. And what will be the current in the circuit? We have total volt, using Ohm's law, we have voltage in, and we have a current, and we have total resistance. So will be voltage in divided by total resistance, R1 plus R2. Then let's apply Ohm's law to the second resistor. We have V2 will be equal, series connection, what you know about the current is the same everywhere. So current times resistance 2, because we're looking at voltage across just resistor 2. Substituting this, we will get that voltage 2 or voltage out will be equal R2 divided by R1 plus R2 times voltage in. So let's calculate what will be the voltage out in this case. Voltage out will be equal 100 divided by 150 times 12. And what it will be equal? More use a mathematical arithmetic. Yeah? It was correct, 8. 8. It will be 8. It will be 8 volts. It will be 8 volts. So this called voltage divider formula, which can be used, but voltage dividers can be solved in much easier way. Can be solved in much easier way. The ratio in which voltage is divided between them equal exactly the ratio of the resistors. So we have that voltage 1, voltage 2 divided by voltage 1 equal R2 divided by R1. That's coming from the current is the same. So we have V, we will have the V2 over R2 equals V1 over R1, which we can rearrange to this one. So voltages are divided in the same ratio as resistors. What is the ratio in this case? What the ratio of the resistors? R2 to R1. 2 to 1. We have ratio 2 to 1. Then we just need divide 12 in the ratio 2 to 1. How we divide number in the given ratio?
2x plus x.
We divide 12 by 3 because we have 3 parts. And how many parts this take? 2 or 1? 2. So, just looking on the ratio of the resistors, we can say immediately that this will be 8 volts. So, solving voltage dividers, you can use the voltage divider formula or look on the ratio. Let's do another example where we will use just ratios. So, let's say voltage in is 24 volts. And we have the voltage out. We don't know what the. We know that this resistor is 20 ohms, and we know that voltage output will be 8 volts. So what will be the value of the resistor 2? So now we know voltages. So if it's 8 volts across this resistor, what is the voltage across this resistor? Total 24. 8 volts across this. What's left for this? 16 volts. So ratio of the voltages is 2 to 1. So what should be the ratio of the resistors? 2 to 1. Dividing 24, so 2 to 1. So this 2, this 1. So what the resistance are to? 10. So you see, if you're using ratio, you can just look on the numbers and you can give answers.
It's always going to be ratio 2 to 1.
Yes, no, not always 2 to 1. Let's make another ratio. Let's say this will be 4 volts. This will be 4 volts. So, and this, let's say 100 ohms. So what will be voltage across this? Total we supply 24 volts. Total 24, how we can get 40? So here will be 20 volts. Ratio of the resistors, we have 5 to 1. So 5 to 1. So this resistance has to be 5 times bigger than this resistor. So what is this? 20 ohms. It doesn't have to be 2 to 1. You just look on the ratio of the voltages and you find resistance. Or if you have resistance and you need to find voltage, you just look on the ratio of the resistances and you can immediately find voltages. But nothing stopping you from using voltage divider formula, which can be rearranged if you need to find any other component. I personally think that this is much faster, easier way ratios, but it's up to you. Either using voltage divider formula or using the ratios. And soon we will learn how this is used to control temperature, control automatic light when it becomes dark, how light is automatically switched on, how it's used, let's say, in cars to switch on when engine becomes too hot, how to switch on cooling system in the engine and so on. Make sense? How voltage divider works. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Hamas, Iran, etc. Support Ukraine and Israel.